region of the Russian Federation, and the Republic has a lot of rivers such as Lena, Indigirka, Kolyma, Enebar, Alenyok. But at the same time, there are some districts of the Republic that have difficulties with water, and they are forced to use lake water. And historically, in central Yakutia, in many districts, they had large lakes, and locals use that water to drink. They also fish in those lakes, and the surface is also very actively used for community activities. At the same time, in the Republic, we are witnessing climate change, and we see that a lot of natural and man-made processes and events occurring, such as wildfires, etc. It all impacts lives of humans and their activities in permafrost lands. And the topic we'll be discussing today is very relevant. First of all, I would like to inform you on the structure of the round table and about the plan. There will be 3 blocks. The first block will be the presentations of speakers, each 5 minutes. Then we'll have approximately an 1-hour discussion, and then we'll summarize for about 10 minutes. And if you will have any comments or suggestions in course of our roundtable, we can actually include these comments to the final resolution of the Northern Sustainable Development Forum. So this is the list of our today's speakers. We also have Innokenty Zhirkov today. And for discussion, we will have a lot of very interesting questions in scope of our topic. You all see them on your screen, so I won't read them out. We'll try to save time. So if you have any comments or ideas about how we're going to work today, you can share them now. If no, then we'll proceed to presentations. So the first speaker today is Ludmila Pistrikova, the senior researcher of the Northeastern Federal University. She is the key coordinator of the interaction between the NEFU and our German colleagues from Alfred Wegener Institute, and also the scientific supervisor of the Biome Laboratory. Please, Ludmila. Thank you. Dear participants and colleagues, I welcome you to our roundtable within the framework of the Northern Sustainable Development Forum, and I would like to thank you for attention and for taking part in this event. And the key object of our scientific interest are the lakes, lake ecosystems, their catchment basins, and lake water, especially in the districts across the river from Yakutsk, is one of the key sources of drinking water for the people. And this makes this research very close to life, very relevant. And although in Yakutia we have a lot of water bodies and large rivers, the problem of the shortage of good quality drinking water is still persistent, and it is very socially significant, especially over the last decades due to climate warming and increasing anthropogenic impact. On the next slides, I will show you the stages of research at water bodies in Yakutia. It's all linked to the Laboratory of Lake Studies. Here we have Innokenty Zhirkov, the leader, the standing leader of this laboratory, and we've been working with them and organized this laboratory, and the work has been really prolific. The Lake Studies Laboratory is inventorizing lakes around Yakutia and in villages, rural communities. This work allowed us to understand how different the lakes are and how they depend on environmental factors, permafrost factors, thermokarst processes. All of this, for me, as a specialist in lake studies, it gave me this impulse to start looking deeper into these problems. I won't go into the details of the presentation because it is pretty wide scoped, and here you can see the dates, when we did what. And at the second stage, we've been doing a lot of educational activities, and we started environmental monitoring in Yakutia within the scope of projects of different levels, including the project Lena Torakyo water pipeline. And in course of these previous works, we've used a lot of different methods, including diatome method, diatome analysis. And this method proved to be very informative, unique, and very highly demanded in many international and Russian projects. In the bottom sediments, these organisms show us all the history of the lake sediment origination. We learn the history based on these microscopic remnants. And this method hasn't ever been used in this region before. And we also have to note that there is stage 3. At the same time, we assessed the quality and the pollution of lakes, and we assessed the natural water quality in cryolithic zone areas in different parts of Yakutia. And again, we used diatome organisms. We outlined the regions, paleolimnological regions in Yakutia, by natural and climatic conditions, and taking into consideration hydrochemical parameters. And we received 6 groups as a result. And the last group, mountainous lakes and river valley lakes, appeared to be interzonal. And you can see that according to the assessment, the central part, or as you can see, the mid-taiga lakes, it's the most populated area of Yakutia. They turned out to be far more polluted than other, let's say, northern territories. It's medium polluted or polluted lakes. And 90% of the studied lakes are very clean or clean. Another interesting fact is that we monitored the changing of chemical composition, morphometric parameters, the case study of Churapcha district or Ulus. In 2017, we studied it and compared it to the inventory of 1978. So what has changed over this 39 years? The mineralization increased, some lakes disappeared, etc. There were quite dramatic changes in those lakes, and the quality of them is not sufficient for using it as drinking water source. The next stage of this of our laboratory activity is studying lakes and their catchment basins. It has to do with collaboration with the Alfred Wegener Institute starting from 2002. And since then, annually, we're holding joint expeditions to study our lakes and watersheds. And within frameworks of this cooperation, we've already had over 30 interdisciplinary expeditions, and they covered the area of 2,000 kilometers from north to south and about 3,000 kilometers from west to east. So we've embraced not only Yakutia, but also some neighboring regions, such as Krasnoyarsk region, Chukotka, and Magadan region. So the baby of this collaboration, I can say, was creation of joint Russian-German laboratory for studying of environmental status of the Arctic, the Biome Laboratory, which was created within frameworks of international projects. It's created based in the NEFU, Kazan State Federal University, and of course at the AWI facilities. And today we have expanded so much the range of methods, objects of research. We have some plans for future. We have good infrastructure, and I hope it will even get better. And I hope our colleagues will mention about it as well. And I'm really grateful to all of you, and thank you for your attention. That was my very short speech. Thank you, Ludmila. And now the floor goes to a specialist for environmental changes, expert in paleolimnology. Or Anna wanted to add something, no? Mm-hmm. So the representative of Alfred Wegener Institute, Ulrike Hertschuh, Germany, professor of Potsdam University.
Yeah, thank you very much. Yeah, I just have two very short slides. I am first want to say that I'm very happy that we are all here and have the chance for exchange of our ideas. I'm also very happy that I was this year with my colleagues from the Northeastern Federal University in Yakutia and got a strong impression how the permafrost ecosystem is related also with the Alas Lakes, and how is this also related to the persons that live in the areas. And that's why we had the idea to announce this round here, this round table in this forum, and so I'm happy to be with you here. So maybe I will take the chance to introduce you to a concept that we have in mind when we think about permafrost ecosystems. And for us is now the question, how does this then affect the water quality of Alas Lakes? So let me shortly introduce you to the concept that we have. First of all, we have, or I envision permafrost as a legacy of the past. So that we have those types of permafrost ecosystems in central Yakutia is related to the cold climate during the last glacial and during the conditions when the ice in the soil could form, and then they could establish such type of ecosystem. And even I consider the Larix forests in those areas which we have only such type of Larix forest, large Larix forests, we have only connected to permafrost ecosystems. So I consider the whole type of this as a legacy of the past glacial climate. And in such type of landscape, then during warmer periods, such as during the early Holocene warm periods, formed thermokarst lakes, and which then became Alas lakes. And now we have again the situation, or not now, but this is a long-term process, so that always new Alas lakes are formed in these landscapes. And for me, the questions are now, so what is actually this past legacy on permafrost ecosystems, and how are these different permafrost forests and lake formation, how is this connected, and what are the tipping points? And then because this is crucial to understand, I think, to understand how these Alas lakes are formed is crucial to understand how are the or what are the ecosystem services before or before and after tipping points. And only if we can understand these relationship, we understand how can we support the multifunctionality of Alas lakes. Ludmila already talked about this. Alas lakes are used in various ways for drinking water, for fishing. So they are used. And of course, we want to conserve their multifunctionality. However, I think this is only possible if we understand the various or the complicated origin of Allah's lakes, and also the various interactions in permafrost ecosystems. And yeah, this is then so this is the one we want to support multifunctionality of Allah's lakes. And the other point is that we want to safeguard these environmental legacies. So we want to safeguard the permafrost ecosystem landscapes. And how can this go together? This, I think, is one of the major questions. And yeah, during our field works this year in summer, we collected a lot of data. Among others, we collected also we collected the drone acquisitions and other information, and we will now and investigated the lakes, and we will, yeah, during the next months and weeks, and together with our colleagues from Yakutia, analyze these samples, and yeah, we are then happy to share this with all of you. Yeah, thank you very much. Спасибо вам.
Спасибо большое, Ульрике, за такое замечательное выступление.
Thank you very much, Ulrike, for your report. And now I want to give the floor to the specialist for studying permafrost soils and thermokarst processes, representative of the Institute of Biological Problems of Krylitisen, Desятkin Roman.
Hello, dear colleagues. My key specialty is soil studies. I started studying soils in Alasis in central Yakutia about somewhere in the mid-1970s. And since then, we've done a lot. We've researched and published a lot, and I've found out a new type of soil formation characteristical for Alas basins. And for that work, in 2016, the Russian Academy of Sciences awarded me with the gold medal of Vasily Dokuchaev for outstanding efforts in soil studies. Soil studies is the basis because Alas is a unified ecosystem. And whether I want it or not, starting from mid-70s, I had to study all the components of that ecosystems, including the behavior and the composition, the sizes, the morphology of the lakes, different humidity belts, different vegetations in Alasis, their productivity, and the impact it had on human ecosystems. Alas ecosystem, to my mind, is a closed cycle ecosystem because it lies in a basin and it has a certain capacity. And the capacity depends on the size of the Alas itself. Sometimes there are very small Alases, just a few hectares, but there are large Alases like Tungulu, like they have thousands of hectares. In general, due to being a closed ecosystem, and it has a certain capacity, as anything in the nature in permafrost areas, they very strongly react to outside factors. The fluctuations of climate, first of all. Our climate is cyclical, it's rhythmical. In Alas landscapes, more or less, we can say that there are impacts of only 2 cycles or rhythms. 11-year solar cycle and 100-year cycle. And the influence of the 100-year cycle I can confirm on the example of one of the large alasses in our thermokarst alasses. It's Tungulu alas. Studying the archives and also the local legends and historical materials and my own observations, I can say that this alas, this huge alas, has experienced 4 stages of waterlogging and 4 stages of drying out, starting from 1620. The first stage was 1620 to 1650. It was a wet period. The lake was at first completely filled. The alas was filled with lake, and then semi-arid climate dried it out. And starting from 1650 to 1672, there was a dry period. And the lakes almost dried out completely. Only about 40 pools, little pools, are left. And exactly then, the ancestors of the locals came to that place, to Tungulu, and they reflected very vividly in their stories and legends. And then, starting from 1672 to 1690, there was another wet period. Again, the lake was completely filled. And in the alas itself, there were 2 little haylands left, but due to impact of this lake, other alasses around started to produce a lot of good grass, and that supported the local economy. And it didn't decline the local economy. And then in 18th century, the large lakes dried out again. We again had some smaller pools. And then to the beginning of the 20th century, again it was the wet stage, and again the area of haylands decreased. And then from 1905 to 1951, again the dry period. And people, especially during the Second World War, they suffered hunger. And starting from 1951 to 2000s, we again witnessed a wet period. The lake filled up, but it started drying out little by little, giving more hayland. And this period ended somewhere in 1998, followed by the dry period, which is persisting now. And based on the example of this behavior of large Tungulu Lake, we can single out, let's call it a century-long changes due to natural changes. So now about the 11-year cycle. It's also very well manifested. It's also very significant for socio-economic development of the districts of the Alasis. One of the lakes, the first lake of the large system of Tungulu lakes, in 1980 it was full. In 1994, due to impacts of the climatic rhythms, this lake dried out, and in 2 years after that, it just disappeared completely. They only had the salt crusts in the deepest places of the lake, and after the wet period of the 11-year cycle started, in 1998, this lake again started to fill up, and it filled up to the size that existed before, in the maximum periods. And after these years, the lake right now is in the dry period. So these are my observations and information that I have. The water in Alas lakes, it's not fully compliant with sanitary requirements. It doesn't always comply with the drinking class quality. It might comply with the technical class. And the less water in the lakes, obviously, during these dry years, the higher the mineralization, and some of the lakes become totally not appropriate for use, either for technical use or for drinking. The largest lake, Tungulu, it has always been quite highly mineralized, above 1.5 grams per liter, and during dry periods it reached 7 to 8 grams per liter. Of course, that's why we have the salt crust on the surface of the soil after the lake dries out. So Alas lakes are very dynamic. In some periods they might be very abundant and very accessible for use by population for any kinds of use, including drinking. But during dry periods, especially at this 100-year cycles, especially during these cycles, in their dry periods, the quality indicators are changing dramatically. So there is fish and then there is no fish. In wet years, people rely heavily on these fish resources and they improve their lives. But a lake disappears and then it gives you additional stress for your economy and well-being. So Alas lakes really do require constant monitoring, and not only morphometric, but also the quality of water should be monitored, and the entire water ecosystems should be studied. What is happening in those lakes within this natural rhythms. And the significance of these lakes is huge. If no these Alas lakes existed, I don't think the Sakha people would have created this unique culture, cattle breeding culture, so close to the Arctic Circle in these extreme conditions. Thank you. Thank you, Roman, for this exciting speech. And now we give the floor to us, the specialist in microclimate and climate change impact on the Arctic, again from Alfred Wegener Institute, Moritz Langer, please.
Yeah, hello. I will speak in English. I hope this is okay. Thanks very much for having me here. That's a really exciting session, and I'm happy to contribute a little bit from my expertise, which is basically on permafrost modeling and usually on a larger scale. And I hope I can contribute something to this discussion here. Now let me try to share my screen. I brought a few slides. So just, I hope you can see this now. Do you see my slides?
Yes, we see.
Okay, wonderful. Okay, I think it's not working in presentation mode, but it doesn't matter. So first of all, I would like to announce, and I don't have to tell you, basically, climate is warming. It is warming in the Arctic, in the subarctic, and it is warming especially fast and strong in the Arctic. At the moment, on a rate 2 to 3 times stronger than on the rest of the globe. And of course, this has a strong impact on permafrost. And we see permafrost degrading and thawing all around the Arctic and subarctic. And it is grading, and this is something we worry about since we are modelers, it is thawing and degrading much faster than our current models predict this process. So our models are not good enough to predict what is happening in permafrost region and permafrost areas, which is unfortunate because we like to provide with our modeling tools so that we can adapt and transform our behavior maybe and also our economics to the changing climate conditions. And if our models are not good enough, then we have to improve them. One of the reasons why our models are not good enough, which we could have identified, is that we have these highly non-gradual, so rapid, non-linear thaw processes. Here are just 2 pictures that you see, photographs of these processes that really makes us worry. These are, for example, thermokarst processes, thaw slumping, for example, thermokarst lake formations, and also gully formation, and associated with these processes, the strong dynamics of hydrology and the water balance, which seems to be so far for our technical possibilities almost impossible to predict. So anyhow, we can try to improve a little bit our modeling, and that is what you see here on the maps. What happens if we start to introduce a little bit more of these complex processes into our models, even so they are not perfect. It's very intriguing to see what happens. So on the left map, you see basically the years when our models would predict the formation of a talc, a 3-meter thick talc in the ground. On the left map, you see these colors. They indicate the year when the model would say, at this point, we have to, it is pretty likely that we're going to have a talc in that region. So it's a very coarse resolution, of course, on the globe, but it gives us an indication here. And then on the left map, you see just basic permafrost as we do the modeling now in the global models. And you see that we have on the edges of permafrost, on the continuous permafrost region, we will start to lose this continuous permafrost region, and it shrinks down to the very high north. And in this light gray area, this is where permafrost would still be kind of stable until the year 2100, if we consider climate warming scenario as we have it at the moment. So keeping the business as usual scenario, basically. So if we start to introduce now a little bit of more hydrology, like ponding lakes, and here it's only lakes that are only maximum 70 centimeters deep in water depth, then we see on the right map how this picture completely changes. So basically, all the talc formation is starting to shift northward, and we have to expect that almost all regions in the Arctic would be then affected by the year 2100 by sustainable talc development, if we keep the climate warming track as it is at the moment. And this is something that is kind of very interesting, I think, also in terms of hydrology in special regions, also in regions that already struggle with water availability, because these talcs are essential to understand how the hydrological system in the region is working. Go to the next slide. Basically, what that means is that we start to thaw the ground and the soils much earlier than we previously thought with our modeling. And here's an example from northern Yakutia. A colleague of mine did this to investigate the availability or the thaw of soil carbon. And these graphs show you basically what changes if we introduce these rapid thaw processes. So if we don't have these rapid thaw processes included in our models, then basically permafrost seems to be very, very stable, at least in this high latitude northern region of Yakutia. But if we introduce these new processes, then you see on this red curve that we can mobilize a lot of, in this case, soil carbon in a very short period of time. And this makes us also worry, not only because of carbon and the potential emission of greenhouse gases, but with this thawing of the ground, other trace materials that are located in the ground are becoming mobilizable. And there's a lot of investigation at the moment going on heavy metals in the Arctic because of natural occurrence, but also because of anthropogenic occurrence. And this material that was fixed kind in permafrost could become rapidly available and mobilizable if permafrost thaws at such rates. There's another aspect I want to point to in terms of water quality, livelihoods in the Arctic, is that we should not only worry about natural processes, but we should worry a lot what we have introduced into the Arctic over at least 80 years of heavy industrialization in some regions of the Arctic. I think, as everybody knows here, since at least 80 years, the Arctic is industrialized, and we brought up everywhere in the Arctic, from Alaska, Canada, and in Siberia, a lot of material and substances that are basically not supposed to be there because of industrialization and military activity. The problem with these substances is that those were often brought into the Arctic with the intention that permafrost is a stable matrix for storing them, and also a stable matrix for the infrastructure which contains such substances. And we know and we observe a lot in the Arctic that those stable conditions are not longer there, and they are steadily becoming unstable over the last decades. And in the future, we expect that this process will continue and become even stronger. So we worry a lot about the release of this kind of material brought in the Arctic, and especially in the vicinity of settlements, and how they would be released in a situation when permafrost thaws and hydrological regions become more connected, and these toxic material could possibly end up in the aquifer, and with that also in the drinking water of the people. So this is a point I want to bring here also on the table, and I'm happy that these aspects are going to be discussed also here in that forum. Thank you very much.
Спасибо большое.
Thank you very much, Moritz, for your very interesting presentation. And now I give the floor to the specialist in the field of geocryology, geoecology.
Лидского отделения Российской академии наук Виктору Васильевичу Шипилеву.
Victor Shipilov.
Thank you. Can you hear me? Yes. I want to dedicate these 5 minutes to the issue of the underground water contribution to the life of the lakes in permafrost. Underground water and surface waters are very closely linked, but underground water and surface water in permafrost have a very specific kind of interaction. It's not fully studied now, but we have to consider this interaction when studying biochemical composition of lakes, their regime, their resources, well, not only lakes, but rivers as well. The interaction between surface and underground water is really crucial to understand many natural processes. Underground waters in permafrost are divided into 3 main types. Supra-permafrost waters that lie above permafrost, the intra-permafrost water, which is inside permafrost, and under permafrost water, or sub-permafrost water, below the lower layer of permafrost. So this interaction between this underground and surface water, especially in lakes, in these types of underground water, is different. But the largest impact on the regime of the lakes and their composition, their behavior, is done by the supra-permafrost water. The waters that are formed above permafrost. These supra-permafrost waters, we divide them into, again, several types, like the upper supra-permafrost, active layer water, and supra-permafrost groundwater. And almost under each lake, can you see it? There is a talik lake, talik zone. Please, can you hold it higher? I'm sorry, I haven't prepared a presentation because I was advised a little bit late and it was too late at night in Yakutsk. So there are talik zones under lakes, and these underground water are very, very closely linked to lake water. Please hold it at the level of your glasses, please. It's obvious that the regime of this supra-permafrost water and their different types has a special impact, their own impact on the water regime of the lake and its chemical composition. For example, in central Yakutia, besides freshwater lakes, there are some salty lakes. It seemed surprising. Why do we have this salty water in lakes? Our research, in particular Nina Anisimova, it's her monograph, the geochronological peculiarities of permafrost lakes, and also the works of her students, say that the significant impact comes from thawing freezing processes, especially at the shore areas, bank areas. When these sediments freeze, the solubles in the water are getting pushed out into lake water, which changes its composition. If it happens periodically all the time, the lake water accumulates all these mineral elements, and we have a high mineral concentration. So these processes are confirmed at our stations. We've studied lake water in different districts of Yakutia, in central, western Yakutia, Viluy group of regions, southern Yakutia. And we have seen these patterns everywhere. Especially how waters generally influence lake water and lake hydrological regime. I have published them in Suprapermafrost Waters monograph. There are 5 chapters where I explained the key characteristics. It has even translation to English. So I explained the key characteristic of suprapermafrost waters, how they are distributed, how they are discharged, how they're used, and how they influence surface waters, like lake waters and river waters. So please, you can order this book in our institute, Suprapermafrost Waters in Permafrost Areas. And to conclude, I will say that the regime of the lakes, the composition of the lake water is very highly impacted by thawing freezing cycles. And these processes should be studied. And we have to find out the role of different types of suprapermafrost and other underground water, how they impact the regime in the lakes. Thank you. Thank you, Victor. Me and my colleagues, we would like to congratulate you once again. You have been awarded the highest decoration of the Republic, the Polar Star medal. Victor received it recently. So congratulations, and we also congratulate you on the anniversary. On September 16th, you celebrated your birthday and anniversary birthday, so thank you for finding time to join us here, and thank you for these interesting ideas. And now the floor goes to an expert in behavior and degradation of permafrost and interaction of societies and landscapes, representatives of Leipzig University, Matthias Ulrich. Please, the floor is yours.
Thanks, Ruslan. Yeah, I will also speak in English, of course. Fortunately, my Russian is still bad after that long time. So I have a small presentation. Where share my screen? Share my screen. Ah, yeah, okay. Can you see it? Think so? Yeah. Thanks for this invitation to be part of this forum. Of course, for me, it's a very interesting topic. As some of you know, I worked in Central Yakutia now, almost 10 years now. Not in always because of Corona, unfortunately, but about Central Yakutia, and my main interest lies in the landscape dynamics, in the landscape permafrost dynamics, especially thermokarst lakes, thermokarst landforms, and the interactions, of course, to human influences on these landscapes. And I studied these landscapes on, or I tried to study these landscapes on different time scales. So I'm also looking for the paleo-environmental situations, how these landscapes are developed during the Holocene. But of course, we are also interested in the actual or recent landscapes evolution and landscape dynamics. Yes, and of course, when I came there, 2012 was my first time. I spent more time around Yakutsk and especially at the UKG study site, and I learned a lot, and I was amazed about these landscapes, especially about the rapid changes of these landscapes and the interactions between human and the landscapes. And from that, we start especially looking to the lakes, especially around the famous UKG study site. And we start also to work with some anthropologists, for instance, Susan Crate, which some of you know from Fairfax in Virginia, or Joachim Otto Habeck from Hamburg. So it was very interesting also to get some information about these anthropological studies. And I would like to start with one of an interview quote from an elder of the Velour region. And Susan created some research, I guess, in the beginning of the 2000s. And and what is especially confirmed is what we already heard from Roman Vasiljevich, is that the land during this time, so the 2000s, often the people have problems to do their hay working or to use the haylands because the land within the Arlasses, so the grasslands, were flooded by water. So Susie called this time land underwater, for instance, and we had a lot of this discussion. So how these situations are changing or changes. And as we heard from Roman Vasiljevich also, is that we have these cycles in the Arlasses of the Arlas lakes, but we also see that we have some quite young lakes, like lakes which just developed on the Jedoma uplands, on the ice-rich deposit uplands, which are rapidly evolving, and the water is not gone. So these lakes are growing and growing. So we start to discuss, so what are the differences, what are the influences on these kinds of lakes. So in first, we did a regional study about lake change detections or using lake change detections by Landsat satellites. So this study was led by Ingmar Nietzer from the AVI. And what we see was that we, especially in comparison to other Arctic thermokarst regions, that we have a huge increasing lake trend in this area between the 2000s and the 2014. So differently than the other regions like in Alaska or also the Kolyma region, we see that the lake area in this region of Central Yakutia was increasing by 50% during this area until 2014, we must say. And what we also see, especially, that we have differences, regional differences on the difference. As you know, there are different geomorphological terraces on the eastern side of the Lena, and we have differences on these different terraces. So the lakes or the water balance of the area is differently reacting. On what? So that is the questions we have actually. What are influencing the different behaviors of the lakes? And we also heard from Roman Vasiljevich that even these differences can change within a small area. So an Arlas lake is growing on the one side, but if we go to another Arlas, the lake is disappearing or not that growing in this strong, not that growing like the other lake. And so we interpreted these results, for instance, that we have, or we see a very large or a strong increase on the Tungelü terrace, which is this terrace, and you can see very good that we have a large increase in the lake area, but we see also areas which are only partly filled or dried out actually also in this area. For instance, the Serdach area, lakes are dried out during this time. So yeah, it's very interesting to know what happens here, why the lakes are behaving like this differently. So, and beside of these regional differences, we also see quite fast that there are differences on younger lakes, which usually evolving on the Jedoma uplands and the Alas lakes within the Alases. And we call the Jedoma lakes, of course, Jedoma, and the Alas lakes. And we did a small study around the Ukechi study site. So I used some remote sensing, historical remote sensing airborne data from 1944. And if we first look on the orange lines, we see the orange lines are represent for the Alas lakes within the Ukechi Alas, and we see this kind of cycle. So we see an increasing of the Alas lakes within the Alas until the 1970s, and then the Alas lakes are still disappear a bit until the 1980s, and then it grows up and the lakes are increasing until 1914. And but we have a look, if we look to the Jedoma lakes on the ice ridge deposits around the Ukechi Alas, but at this point we need to explain that these lakes are evolving in agriculture areas, so areas which were used agriculturally until the 1940s, 1950s, and then they need to abandon because of thermokarst processes. But in these areas, the lakes are growing very, very fast, and they are still growing. So, and I have a photograph, a very famous photograph timeline from Alexander Fyodorov of one of these lakes. So it's the lakes is the lake in this area we see. And we see this lake growing within 20 years. And now the lakes have a depth of about 3 meters, on 3 meters until 4 meters in this area. So the Jedoma lakes around the Ukechi study sites are today around 4 meters deep, while the Alas lakes are shallower, around 3 meters, 2 meters, 3 meters deep. And during a drilling campaign, I would like to say, in March 2015, we measured pH values and electric conductivity, and all the lakes have a surface water pH of 8 to 9 and an electrical conductivity between 2.5 and 5 millisievert per centimeter. So the snow in the areas has only electrical conductivity of 0.1 millisieverts per centimeters. So this is showing what Alexander Roman Vasiljevic said already, that the minerals goes very fast during the thermokarst processes, during the permafrost degradation, goes to the lake water. Yeah, from this, of course, we did some climatological studies and try to explain why the Alases, or what is influencing the Alas lake changes and what is influencing the Jedoma lake changes. And we could say that the lake changes, or the lake growing, is mainly influenced, from all lakes, is mainly influenced by winter precipitation, winter temperatures, and also by active layer, or water which is stored within the active layer. But for the Jedoma lakes, there is a quite larger influence of course of melting ground ice. So at this point we did some observing the lake changes during the times from 1944 to 2014, and try to predict this by a quite simple regression model. And what we see at this time, and what we conclude in this paper 2017, that the area is wetting and the lakes are still growing. But then 2 years later, I get a photograph from Sasha Fyodorov, where he showed me that the Alas in the Ukechi Alas was almost completely dried out. And that is, of course, very interesting and gives some questions, which I would like to bring to discussions also. And the main question for me is, finally, which effects are to be expected for the water quality and availability in Central Yakutia by the cyclical changes of the older Alas lakes and or also the anti-cyclical changes of the younger Yeruma lakes. So with that, I stop and thank you for your attention.
Спасибо, Матиас.
Thank you, Matthias. And we are giving the floor to our next speaker, to leading limnologist of Yakutia, founder and head of limnology laboratory of NEFU, Innocentii Zhirkov.
It's really a pleasure to see the people who devote themselves to lake studies. They are very difficult, they're very complex, and I'm really happy to hear about your achievements over the last years, and that us, the lake scholars, we have come a long way in this direction. So I would like to congratulate all of you on this. And I think that interest to studying lakes is growing despite all the COVIDs and everything. I just will provide a few pinpoints because there are a lot of challenges, a lot of issues. Some of them can be solved, some of them cannot, but I will just list briefly some points. So here are 10 most burning, I'd say, problems of lake studies, not only in central Yakutia, but in Yakutia in general. First of all, I would like to draw your attention to the large number, an endless variety of lakes in our vast region, in the depth of Eurasia. And the main thing is that 1/5 of Russia, of the territory of Russian Federation, is Yakutia, and 1/3 of Russian lakes are in Yakutia. If we take not only central, but the entire Yakutia. The second, we didn't have almost no surface glaciation during Ice Age. We had underground glaciation because the region was very large, a large lump of land. That's why these air masses could not penetrate too deep into Eurasia. That's why the glaciation was almost all underground, and everything has to do with that. What else? Based on different resources like water resources, land resources, biological resources, and other resources of the lakes. Yakutia has developed the northernmost cattle breeding culture. Both cows and horses are bred here, and it's unique. We have it only here, almost embracing the entire territory up to the Arctic Ocean. And this is due to using these lake resources. The richness of our agriculture, the cattle and the horses. This is all thanks to the lakes. Another thing that many of you mentioned, is the variability, the changing climate, the changes in the waters of the lakes, the changes of resource abundance. It all influences our lives, our economy, our health of local people. And that's why lakes for us are life source, and they are very important, and they need to be studied more deeply at a larger scale, at a wider scope. And in connection with this, you mentioned variability, but variability can be also different. There are cycles, there are rhythms, there are periods, and they don't coincide. They overlap, they interact, and these pictures you showed, these photos, the maps, old maps combined with new data, everything has to do with climate change. And we know so little about it. And the modern warming, how long will it be? How deep it is? How will it impact our lives and economy? We don't know that. So we can have some hints from studying our lakes, which we are all engaged in. And you brought very good data, it was very interesting, and your conclusions are also very valuable, so let's work in that direction further. Next point, or problem, I would like to mention that we have no standards, state regulations, or definitions of the quality of drinking water. We don't have the item of soda. I talked with Alexander Perelman at some point and worked with them. And we wanted to find out what is it, how it influences health of people and cattle. But we didn't find answers. Although Alexander Perelman, everybody knows him as the most outstanding geochemist in the Soviet Union. And in Russia he also worked. So it's a completely unexplored field for research, the soda content. And we need to develop some rules, regulations, limitations. And again, we understand it very differently. Different publications understand soda content in different ways, and we don't have any terms of reference. And our region has very high content of soda in waters, and this content is variable, again depending on the changes that are occurring. So this is still an open question. Next thing, it seems like we have the majority of freshwater lakes that can be used for drinking, for technical purposes. But on the other hand, we have to note between the lines that actually there is a whole variety of different salty lakes. And they also have very different origins. I will just remind you that Kempindyai depression has about 30 different types of structures with salty tectonics, if I may say so. And 14 out of them are open anticlines and 16 closed anticlines. And there are so exciting, interesting lakes with such different mineralization, with very differing morphometrics. So that's a whole separate topic for further research. And just to bring some examples, the soda salinity for us in Yakutia is also pretty characteristics. Let's mention Abalach mud recreation resort and all those medical muds that we have there. The technogenic impact on water lakes still are to be studied. And coming to a conclusion of my short message, I must recall or remind you, underline, the organizational structure, the funding, the funding of research was very active for lake studies back in times when we had our first president of Yakutia, Mr. Mikhail Nikolaev. He was a strategic thinker, and he was thinking about future, and he was very different from the leaders that we have now at all levels, municipal, regional, federal. So we expect them to actively support our research to forward our very important studies. And the last thing, in order to coordinate and intensify and to summarize these studies, the Laboratory of Lake Studies in the Northeastern Federal University, we are thinking about publishing a 8-part guidebook or data book of lakes in Yakutia. We already published some, but for the last 5 issues of this set of books. We need to do some more expeditions, field works. This will be very difficult because we'll have to organize transportation, etc. 625 plus minus 1/2000 of lakes we have in Yakutia, according to the official maps. 1 centimeter, 1 kilometer scale. Does it impress you? 625,000 plus minus 1/2000. In 2 regions of the 8 outlined by us, we already completed the content of this reference book, and we hope to get some more funding. So there are many people who expect this publication very much. Actually, there are no lake guidebooks in the world. There was one published back in Soviet times in Belarus, with whom we worked. And the second one was published by St. Petersburg Lake Studies Institute together with Petrozavodsk. And they published this guidebook, but we haven't anything else, only separate materials on individual lakes like Baikal, etc. So we still have a lot of work to do. But I'm not getting younger. So out of you 3, I know some of you from the university, some of the alumni maybe of our laboratory. And to conclude, I will say that studying lakes requires a lot of physical, organizational, and research efforts, financial efforts. They are indispensable, and we have to enhance these studies, limnological studies. If you approach limnological studies only with oceanographic methods, but in fact it should embrace everything: economical, theoretical, landscape studies. All of this requires even wider and deeper approach than usual oceanographical studies. So lake studies are mobile compared to those classical oceanography. So I wish all of you great success in your research of the lakes, and I hope that we will keep our close cooperation. Especially now we have all the tools for it. As you can see, we can now contact each other easily. During this pandemic, the conference of lake scholars has been postponed, so we don't hear anything from there, but thanks to the tools that we have now, it turns out that we still can keep up our contacts and share our interesting ideas. So thank you for your attention. Thank you, Innokenty, for this very detailed message about the problems, lake studies, the problems of studying lakes in Yakutia and outside the Republic. And now the floor goes to an expert in geology, geomorphology, Arctic climate change in central Yakutia and outside our planet, expert of the red planet of the solar system, the representative of the Paris-Saclay University, Antoine Séjourné. Please, the floor is yours.
Доброе утро или добрый вечер.
Good morning or good evening. Thank you. I talk a little bit in Russian and in English.
Again for inviting me to speak to this round table. I'm gonna share a small PowerPoint. It's gonna be here. I hope everyone can see it, or yeah, all right. I'm looking for the, all right, pointer. So thank you again for inviting me to this round table about the water quality. I will try to speak and give a different perspective, which is complementary to all the nice talk that was presented before about the water quality. I'm a geomorphologist and interested by geochemistry. My main background is geology, so in between. And I would like to talk about the understanding of the impacts. So there is a plural to impacts of permafrost thawing to hydro system. And for me, it's a very important. And I would like more to talk about the impacts on small water catchment that are a bit understudied at the Arctic scales, and it's a right topic for today's roundtable, because at the small water catchment, you can really study and pay attention to all the different processes, cryological, climatic, and anthropogenic, that can play a role and produce a broad diversity of impacts to the lakes and to the river as well. So I'm gonna pass more about that, of course. Just here a slide to show it's pictures of inside the salt slums of the Chungulu terrace. Just to say that, well, you all know where about that, of course, that permafrost, we talk a lot about carbons, especially organic carbons, but permafrost contains a lot of inorganic element, not only carbons, which is main focus because of the climate feedbacks in our climate. But there is a lot of different stuff, and we saw with today that the salinity of lake are very important, especially with alaces. And it's also important to understand how the chemistry of lakes evolve, of the current lake. Lakes are developing because of thermokarst, in order to understand how they will evolve in the future for alas, and of course, how alas will evolve in the future. So we know that in the context of global warming, the thermokarst lakes are dynamic systems that are biological hotspots that release organic and inorganic element toward the atmosphere, but mainly and more importantly to the water system, to the underground water, to the groundwater system, which ultimately led to lakes, who, if they are not connected, but as well to small river that then flow toward the Lena River. So it's something important. There are different aspects to it. And by looking at the lake water chemistry, what I was really wondering is that one main component, which is very important, is what is the chemistry, what is the mineralogy of the permafrost of the terraces, and as well of the active layer, because it's where all the water transfer is going to happen, and it's going to transfer a lot of solute element to the lake and ultimately to the river and to the Lena River. So this is something we know. What is also interesting to see here, it's a picture of the Sirdar area. Here it's the Sirdar settlement. It's our main study site. We come here since 2012, 10 to study the thermocast development, but as well to study the chemistry of lakes, geochemistry of lakes since 2017. And which is important here is that you see that you have a diversity of lake. You have diversity, of course, in topography. You have some lakes that are, you have Alas lakes. Some are connected by the river. Here's a small Sirdar river that connect to the Sirdar Ozero. And then ultimately go to the Lena toward the west. Some Alas connected, not connected. And we have, of course, recent lakes that are actively developing. Some developed some years ago and not seems to be very active. Some are very active today. It's also something that talk Matthias and the other. So it's interesting to see that you can, all of this can interact. You can have lakes, for example, small lakes, which is not the case here, but it's the case here. Small recent lakes that it seems to have some underground flowing to this Alas Lake here, which has a higher salinity than the other lake. I'm going to show a bit later. So just to say that we have different processes, it's important to study the geomorphology as well as the chemistry. I would say that if you study the chemistry, it's important to know what's going on, and because you can have a broad diversity of chemistry that can be explained by what's happening on the surface and under the ground. So different lakes, some are connected or not to the river. Show you. So in the end, so many other people, scientists, and more recently myself, are interested about the mineralization of lake water. And here on the graph is one graph to show a bit the diversity of lakes and how to explain it. So we have a graph of sodium and with magnesium. Sodium is very nice because it's directly related to salt, sodium and chlorine. So in blue, we have the Alas, which are unconnected to the river, such as here. And we have in purple, Alas that are connected by the river, as well as in green, the river itself, which is here. And in red, we have the more recent lakes, so wide diversity. What's interesting to see is that you have really striking two groups. One group which has low mineralization, so low content of sodium and magnesium. It would be the same if I show electrical conductivity or total dissolved solids in milligram per liter. It's exactly the same pictures. So one which is low mineralization, and one, the two other group that are really highly mineralized with the Alas Lake and the recent lakes. It's interesting to see because when we think about the thawing of permafrost and thermocast development, okay, we have organic and inorganic element coming to the lake water. Makes sense, they are bigger. You have more and more element coming from the permafrost to the water. So you improve and increase the mineralization, which is quite straightforward. But we were surprised to see that some Alas Lake have very high mineralization, and not only due to salt. So if we look, but as well due to, so it was 2017, 2018, but also due to the climatic process. So for example, the Alas Lake, we know that they have high salinity, like most of you talk about it in a better extent than me, directly related to the evaporation of water and the freezing and melting cycle of the water. Of the sediment as well, that increases salinity. That's something interesting to see. Which is also interesting to know is that for the recent lakes, we have different mineralization, which is not necessarily due to the development of lake. Oh, I seems to have some, I'll show you before, yeah. Not only due to the thermokarst development. For example, we have some lakes that are formed in Cedar area in 2000, some lake in 2005 mainly. And it doesn't mean that the ones which are older have a highest mineralization, because they can stop or it can have other processes that change the chemistry, not only just subsidence and formation of the lake. We have a lot of runoff and slides on the side that can change, like we can see here, in comparison to this more recent lake, that some of it can be very active. So in terms of chemistry and salinity, there is some change due to thermokarst, but not only. It's something need to be studied. So that's for the recent lake. But if we look at, I'm going to show you here, at more the lakes that have low salinity, low mineralization, such as the one that are connected by the river here, which is here, for example, this one, Sirdar Lake next to Sirdar area. They have a low mineralization, which is interesting in comparison to the other. Can make sense. They are the only one connected into these small watersheds from the Abalar Terrace to the Tiongulu Terrace, where the lake is. And it's also an important lakes, because these are the one that I was not an expert in that. I just learned when we came during winter and by talking with all our colleagues, such as Sasha Fedorov, that these are the lake that are used for drinking water to collect the ice in the winter. And so this lake have low mineralization, low salinity. So it's okay to get the ice. But what we're going to see in the later is that these lakes can change. So we have these three types. But it's a complex system, because you not only have lake connected by the river, you have an ongoing change in the landscape due to the thermokarst. For example, on the lake of this lake, which is upstream of the Sirdar Lake, we have a lot of thermocirques, which are area where we had salt slumps. And these salt slumps can change. They can be very active, very large. They can bring a lot of solute sediment and mud flow to the lake, as well to the river. They can mix to the lake river. They can be quite active. We studied them in 2015, and we showed that they can retreat and develop up to 5 meters, sometimes 10 or 20 meters per year. We see similar salt slump happening in on the coast of the Arctic oceans. What we were surprised in 2019, we were visiting some Alas Lake, and we found that there was an Alas Lake that had just recently, the year before it didn't happen, a salt slump on the side. And these salt slump were created by the water pipeline to the Borogon area that were broke, or they understand if it was not, the valve were not closed. Anyway, it created really big salt slumps. We can see here that completely changed the geochemistry of the Alas Lake. It was also seen elsewhere in the Arctic that it's a release of solute sediment and sediment and solutes change the chemistry. It was interesting because it was completely cut a small road, and we were lucky to come back this year into Yakutia to sample again this Alas Lake. There was another one there, which an older salt slump, but this time not due to a pipeline, but to the drainage of the recent lakes. And 2015, the salt slumps is stabilized, but the lake still show delta and still show a very high conductivity. And we would like to analyze the chemistry. So coming back to the thermokarst, to the lake near Sirdar, we have stabilized a salt slump on the side of this lake, and we were really wondering what will happen if these salt slumps are active. How are they going to change the chemistry of this water, of these lakes, and how the water quality will change for the people getting the ice for drinking water? Is it going to be it's exactly the same, good to drink, or you're going to have some problem because we have some elements that are released to the system. Fortunately, these salt clamps are not active since 2012. They're inactive right now, but before they were very active and developing actively. We couldn't get chemistry at that time, which is here is in 2010. We got it after. So we will try to study that in the future, but we can already compare with the site I previously showed. Just to say that we have a recent project called Belmont, called the Permafrost Degradation Impact on Soil, with people from Permafrost Institute, Moscow University, Biological Problem, and Lomonosov State University, and other people from France. And we would like to compare different sites in Central Yakutia, as well as Igarka, with some sites in Alaska. So we will continue to study the water geochemistry of these lakes. And just to finish, I got some questions that we can probably follow up. Is it how it's going to evolve in the future, this Alas and recent lake? How can we compare them? And also what I was really interested in is how do we share to the local community? We go to Sirdar settlement since 2010. People were wondering, what are we doing here in Sirdar? What are we doing? Now that we do a lot of activity with children at school, they are more and more interested about why are we studying the chemistry of lake, what it is, what can tell us about the evolution. And it's really an idea of how to share, and is it interesting for them, and how can we pass this knowledge to this local community. Thank you very much. I'm finished.
Спасибо большое, Антуан. Ну что ж, мы заслушали.
Thank you very much, Antoine. So we have listened to all the speakers today. The issues raised were very interesting. They are all connected together. And now we are moving to our discussion part. And I'm going to show you how the issues that we should discuss.
Для обсуждения.
I will ask, we only have 15 minutes for the discussion, or I think we can prolong our session, because the first part was a little bit longer, if nobody's against. But what about Zoom organizers? No, everything is okay. We don't have time limitations. Okay, the first question, but we'll have to keep it real quick because we spent a lot of time. But the presentations were very interesting. So the first one, how do climate, permafrost, vegetation, and Alas lakes interact? The question about interaction of different natural ecosystems. So if somebody has something to say about this, maybe Roman Vasilievich. Yes, dear Ruslan, in my speech I mentioned that the picture of Alas ecosystems at any span of time reflects the state, the status of climate. It very strongly reacts to climatic rhythms, and they are interlinked. So Alas systems are closed cycle systems, and they have a limited capacity. That's why they react very fast to climatic change. And permafrost recently is starting to thaw. The seasonal thaw depth is increasing in central Yakutia compared to what we had 30 years ago, about 2 or 1.5 times, and it leads to stronger thermokarst processes, and water flows where? It flows to Alasses, depressions, and when the seasonal thawing layer, if it increases 10 centimeters, it can release up to 30,000 cubic meters of water. And where will this water go? It will go to rivers or Alas lakes. So global climate change will increase the water quantity in the region. And the composition of this water is not like in Alas lakes. It's more enriched with reactions with natrium, magnesium. It also increases the mineralization of lakes. And that's it from me. Thank you, Roman. It was interesting to hear to your expert opinion. Maybe somebody has to add something. I think every reporter, in fact, every presenter mentioned all those interactions and links between all the components of the catchment ecosystem. And I think everyone underlined it in their presentations. So maybe that's a question that we already have answered. Maybe let's move to some other ones. Do you agree, colleagues? Okay, let's go to next question then. Question number 2, how these interactions will change in future? It would be interesting to hear something from the AWI colleagues, maybe Ulrike Herzschuh, because she's such an interdisciplinary expert.
Ruslan, I think when we think about the interactions, maybe we need to think of how will these different variable or how will climate and how will fire change in future, and this will then affect vegetation and then maybe also the Alas lakes. So we had a look to future predictions, and actually the prediction how climate will change in Central Yakutia, they differ between the different models, particularly with respect to precipitation. So it is quite unknown how, still quite unsure how precipitation will change in future. And what I understood from the investigations, for example, of Matthias Ulrich, this is a main impact on lake level, and I think this is mainly then also related to the mineralization of the lakes. So I think to understand how precipitation will change in the area would be key to understand also how the Alas lakes will change. And besides, it is not only for lake level, but it will also, the precipitation will also impact the vegetation state, and because it will drive the fire, and then via fire again, it will impact the lake or the lakes. And that's why I think maybe it would be a key to better understand the future changes, or how was precipitation in times of warming climate. So this is for me a key. If we understand this better for Central Yakutia, I think we can also make better predictions for lake changes. So this is the natural side, yeah, and the other side, how will more and more water is more and more used, or alases are more and more used in the area by human. And I think this is for me a key question that I have to you in Yakutia. What is your expectation? How will land use change in future? So what different types of land use you expect for the future?
Так, вот. Прошу прощения, у меня связь прервалась.
I'm sorry, I had little problems with connection. This question, I think it's in the list of our questions, but I would like to add or mention that unfortunately the older Alas lakes, their capacity, their potential for deepening is no longer there, because it all depends on the ice complexes that thaws when the area of the lake increases, but then the lakes start disappearing. But young thermokarst lakes will be appearing, and probably there will be new Alases. This was my addition. Maybe I was a little bit too not very clear, but I can explain if you don't understand. So the capacity for further deepening of our lakes is finished. In central Yakutia, the maximum depth is 8 meters and the mean depth is 3 meters. It's the depth of thermokarst lakes. We don't have any deeper lakes. Thank you, Ludmila, for this interesting point. Maybe some other comments? Yes, sure. Victor? The first question. How climate, permafrost and vegetation will interact? The first question was how climate, vegetation and Alas lakes interact. I would like to add one more factor to this, because I mentioned it in my message. I would add underground water to that equation, because in permafrost under each lake there is an underground lake, which is connected to Talik zone of this lake. So the link between regime of underground and surface waters, there is a very strong linkage. We cannot study surface waters without studying what is underground. Another thing is that we have to maybe somehow clarify the classification of permafrost lakes, in particular in Yakutia, because we have different types of lakes. There are Tukulan lakes, and I was amazed by them. They are so different. In such a uniform landscape, desert, sand desert, but the lakes are so different. There are some other types of lakes, shallow ones. There are lakes with fish, and the fish species can be uniform, but there are so-called Sephosian lakes. They are round and their depth depends on the diameter. There are 20-meter diameter lakes and their depth is up to 15 to 20 meters. Then there are 70-meter diameter lakes and their depth is about 70 meters. And the biota there is also very different. Some of them only have one type of fish, and the deeper the lakes, the larger these fish get. So there are so many exciting things about these lakes. Maybe one of our tasks should be improving the classification of lakes in Yakutia based on current available data, including interdisciplinary data. I think that's a question for the next conference, maybe. Maybe we should even put it as a title and organize some workshop, maybe international conference. Thank you, that's interesting. Ruslan, I'm sorry. I became interested. What classification do you mean? Morphogenetic by Innokenty Zhirkov? Landscape genetic. Zhirkov's is landscape genetic. Not only genetic. Oh, can I add? Innokenty, yes. The classification is there for quite a long time, but it was a draft one. And then in the book Rivers and Lakes of Yakutia, published by the chair of geography, they have enhanced classification. And there are 8 types, 9 subtypes. And I don't remember how many, but around 20 or 30 groups and subgroups, and also anomaly lakes that cannot fall under any classification. And regarding the depth, yes, there are very interesting deep lakes, 78 meters Big Toko, 64 meters in Kimpindyai lakes, then other lakes with 60 and etc. The lakes are different in size and depth. And another thing I wanted to mention, of course, we should improve the classification. Yes, it's a very good point. And the last, about our colleague mentioned the quality, the chemical composition. That was actually a very good thought. How the taiga fires influence the hydrochemistry of lakes, because sodium content probably might be linked to those wildfires, because you understand, obviously, after the fire you have a lot of compounds and elements turning from organic into mineral, and they end up in lakes. So probably that's the origin of sodium lakes. Thank you. Maybe I'm mistaken. We all do some mistakes. We all are searching in the darkness most of the time. Victor has also mentioned a very good thought, and we've been working a lot together. The Institute of Lake Studies has also very good works. Hydrothermal studies at Sirdach lakes. Those works are classical. Thank you. Thank you, Innokenty. I think today it's very relevant due to these wildfires is how does the change in vegetation influence the system of interaction between climates, Alas lakes, permafrost? There are less trees, and they play a very big role in connecting and regulating the water regime. At the same time, each tree consumes a lot of water, a big amount of water daily. So if we lose trees due to wildfires, how does it influence lakes? I think that's another very interesting question. And we have mentioned some aspects. Maybe colleagues have something to add, or we can move to the next question. Unfortunately, we don't have that much time, so I suggest that we proceed to the next question. What can be done to save the water supply and quality in future? That's a very important task for us. Can we do something at all? Dear colleagues, maybe you have thoughts on this question number 3. I would ask here Roman about the people of Tungulu. What do they eat? We mentioned that the quality of Tungulu Lake and the basin is not compliant with the standards. So what water they use? What do they drink there in Tungulu? Thank you, Ludmila. The drinking water, it has to do not only with Tungulu population, but the entire Sakha people. Our ancestors, understanding that the quality of water in lakes without any chemical analysis, they understood that the quality of water in lakes is not very good, and they were not able to use it and to drink in winter. In autumn, when the ice started forming on lakes, they started taking the ice out. Why? Because in autumn, when the temperature drops, especially before the surface water freezes, in every lake you have a stratification. Due to low temperatures, all the particles and salts, they go down, and the upper layers of the freezing water are somehow purified, and they get rid of minerals, particles, and the locals started procuring ice for drinking water. In order to preserve this ice, they dug out the cellars in the ground, and they drink this water almost until the next summer. So at Alas regions, the problem with water quality was solved using this method. It's folk wisdom, and it proved to be very correct. But for larger settlements, you can actually don't have enough ice, enough quality ice for drinking water. But in those places, in Soviet times, they started looking for, prospecting for underground water. First, they opened up Talik waters, then intra-permafrost, sub-permafrost waters. And right now, the majority of larger settlements are provided with water from Taliks and underground and even artesian waters. They have also purification installations, of course. Even in my native Tungulu, back in the early 90s, the sanitary authorities closed the water hole because it didn't correspond to the requirements, because in Soviet times these purification plants were not that efficient, probably. And then in 5 years they gave a new permission to use that water from the hole, because it was, since then it started to comply with all the requirements. So the quality of water in Alas district, it's not that crucial, and I hope it won't until we have these cold winters that can provide good quality ice. So that's my thoughts about drinking water. What else? So you mean that procuring ice for drinking water is the only alternative for the majority of smaller communities in the rural areas? Yes? Yes, that is right. If you don't have a hole, yes, of course, that's if you don't have a well, then that's the only alternative. Dear colleagues, do you remember that experience in early 2000s? We discussed it with Ludmila today, to construct water pipelines, Lena Torakyol and Lena Muru. Has this somehow helped, or not much changed in water quality? I can also answer to that. It all had to do with the forthcoming drought periods. In early 90s, we witnessed a dry period in central Yakutia, and all large lakes just dried out. Only smaller stayed, and it wasn't possible to even procure ice from that, and it was a problem, and people started asking, give us water. It was in the early 90s, late 80s, and the Republic in 1991 became a independent region of Russia, and they decided to help. And thanks to funding from Alrosa Diamond Mining Company, they constructed this pipeline to Baragonцы first, and the next pipe went from Lena to Torakyol in Tata. And at first it was planned to take water from Amga to Sola, where 1/3 of the population of that region lives. And but the people of Amga region, they were against it. Nevertheless, although it wouldn't actually cause much damage or shortage of water to the locals, but anyway, there were these populists who insisted that they didn't construct that pipeline, but still other people want that water, and cattle population was decreasing due to that. In 1993, they decided to take water from Lena River and built a pipeline from Lena to Torakyol, which was 160 kilometers long. It is actually many times longer than the first plant from Amga. So it was longer, it was more expensive compared to the first option that was abandoned. But still, they didn't have choice. They built it. And during the drought, several lakes in Tata Basin, and in early 2000s, the water reached Tungulu. So it helped people.
Потому что и даже если сейчас в
результате
климатических изменений очень сильные поступления дополнительной влаги озера Ленонгинское междуречье состоится, то это трубопровод может послужить откачке этих вод.
If we have too much water, this pipeline can actually work in the other direction to pump the water out and save the hay and grasslands. So I think the investment was, well, in general, it was worth it. I think Antoine wants to add something.
Thank you. I just wanted to ask that it's kind of a question, and Sally made a small comment. Like, we're talking about water quality, so we see that all of us are more physical or geographers. So we understand water quality is the heavy metal element. This is important, turbidity as well. But maybe if we discuss in the future about water quality, we should invite microbiologists, because the microbiology analyses are important for the water quality, especially for drinking for people. Like analysis of bacteria, Escherichia coli, are important for to assess if the water is drinking or not. So just maybe for the future, we should have. I don't know if in Yakut there is a microbiologist in PI. I don't think so, but I'm not sure. Is it?
Ну, я скажу, что
the closest lakes to the communities, especially where they have cattle farms, horse farms, the water from those lakes is absolutely not usable. The maximum parts per milli, the elements that you mentioned, it's just several times larger than it should be. So they are not used at all. And people know exactly where the clean lakes are without anthropogenic impact, and they take ice water from there. Even in summer, they use it for technical water. Just you have just to know where the lake is, and that lake is usually somewhere far from the community.
Можно добавить, да?
I will also add, yes. In the Republic, we have many lakes of spring genesis. They are fed by springs and creeks, and although we don't have them in classification, although we probably should, how many such lakes there are in Yakutia, where they are, for example, in central Yakutia, where permafrost is about 350 meters, what springs you can have, but still you have some. There are some all year round high debit springs, and you also have spring lakes. Across the river from Yakutsk, we found Ungustyach Lake. It is a spring origin lake. So these lakes don't depend on climates or wildfires, and their regime and quality of water don't depend on all these factors that we mentioned. So again, I'm going back to the importance of knowing the genesis of the lakes. Again, spring lakes can be different. Some of them are charged by a deeper sources, sub-permafrost sources. Some of them are charged by intra-permafrost waters. Again, we have to classify them. Thank you.
Moritz Langer, желает.
Oh, also, Moritz Langer wanted to add something, please.
Yeah, it's more like a short comment. I think that I don't know, especially in the Yakutia region, how also wastewater management would be an important aspect here to be included, because obviously, as was already discussed now, like used water or regions where there is farming going on could be problematic, but also like water that was used already by human and is somewhere it must end up. And that I think is an important aspect to consider future water quality also in permafrost regions. And I think it would be also important to consider that with permafrost thaw, maybe aquifers that are right now disconnected over some certain distances will maybe eventually become connected because of the thawing of permafrost and the formation of streams. And that might cause future problems and aspects that should be considered maybe as well.
Спасибо большое, коллеги.
Thank you very much. Colleagues, let's move to other questions because we're limited in time. Ulrike, Hertschu, and Matthias will have to leave us soon. And that's why we'll move to the next question. Number 4, how the water quality will change in relation to permafrost degradation. Actually, we have already partially answered this question, but if you want to add something to it.
Тут я думаю, что уже много было.
I think a lot has been said. Yes, we already mentioned a lot of things, because the relation is there. Yeah, we just have to keep on studying this issue, and that's a big task. Okay, then. And question number 5, how the water quality change in relation to thermokarst lake size and type. Ruslan is having technical issues. And I think question number 5.
It's similar to question number 4, no?
Yes, it's similar. But can I add 2 words about climate change and water quality? Just a few words. Can you hear me? Yes. I just want to remind that in 1512 there was the revolt in 1512 there was a revolt in Netherlands, and the ocean was completely frozen, and they used skis or skates to reach all the Spanish ships and burn them down. So just imagine how cold it was. Right now we can't imagine how you can skate, but it happened only in 1512. It's really recent. So there will be changes in both ways, warming and cooling. The global change, continental change will be there. And the lakes also will be changing in quality, quantity, sizes, etc. Thank you. Thanks. And I will add that the bulk of Eurasian lakes, including Yakutian lakes, they originated in Holocene. Let's put it like that. So it's just 10,000 years ago. It's a very short period for geology. And we don't know actually what will happen next. It's hard to forecast. All those reconstructions are done only within this time frame. We don't have really many ancient lakes, or some of them don't have, let's say, Toko, the big Toko. We don't have information on paleo status. Not everything is available for studying. That's why we don't know what will happen next. Thank you. Thanks. Number 6. Could the thawing of permafrost increase water availability? Probably yes. Sure, but the quality will be even worse. Any other opinions to number 6?
I would like to add something. It's also a matter of the, we know we are,
Да, конечно, Антон.
the temperature is warming. The question is also how the evolution of precipitation and snow as well. I mean, when we look at the data, it's not clear if we have an increase, but if we look at the CMP5, all this climate model simulation compiled by the IPCC, doesn't matter the RCP 4 or 8, they simulate that there would be an increase in precipitation, but we know there is some problem with the accuracy. There is wide variety into the simulation, but they show that there will be an increase. It would be interesting to see if there would be an increase or not of annual precipitation. I won't even say into the seasonal aspect, if it's really different than the modelization or not. I don't know if someone has also something to add about that, because we know it's important, the precipitation for the water balance.
Я почему говорил насчет укущения качества воды?
And I just wanted to explain why I mentioned the deterioration of quality due to climate change, rising temperatures, longer warm periods. In Yakutia, we have some processes with the components of all the components. Every year we have new species of insects animals, fish,
лет 40 тому назад
and
Атласные
plants.
озера в летнее время они не знали, что
In the past, in summer, Alas Lakes
эти озера начали
never went green, but starting from 1990s,
флора так сильно разбивается, что некоторые озера полностью
these lakes developed very intense algae vegetation.
водорослями. Это водоросли, они, конечно, меняют не только качество воды, но и это
And it changes the quality of water.
существование водных животных.
But the conditions for fish, our favorite fish, and this has a very impact on lakes. And these
раньше вот этих озерных чаек
comes with birds. These we didn't have lake gulls back in, let's say, 1960, and since they appeared, the lakes turned green in summer, and it depletes the oxygen content in the lake. And our aboriginal, very useful fish are very much stressed.
Спасибо большое, Роман Васильевич.
Thank you.
Еще можно добавить, да?
Да, конечно.
And I can add also.
Мне кажется, что тут
We should also take into account the following factors. Accessibility, availability of water when permafrost melts. Each lake has a catchment. It's not very big for Alas lakes. In other types of lake, it can be bigger. And here the influence of warming climate to the quantity of water in the lake depends on how ice-rich are the rocks in the catchment. If there is a very well-developed ice complex, then the thawing of this permafrost will bring more water to lakes. But there are many lakes where catchment only embraces ground where there is very little ice content. And in such catchments, the thawing of permafrost will not enhance the availability of water. So it really depends on the specific conditions. Next question.
Они тоже очень интересные.
I think they're also very interesting. Number 7. How strong is the human impact on the water balance of the Alas lakes, and can or should it have a regulating effect?
Потому что он является одним из...
And I think this will be interesting for Antoine, because he's one of the inspiration for these questions, actually.
I don't know if I can fully answer. It's I won't talk about the Alas because that's not my expertise. I think Roman, Matthias, and other can more talk about that. For Alas Lake, but for the one connected by the river, it's for sure it's strong influence on this water quality. And the thing is that for myself, I don't really fully understood. And the problem is that it's difficult for us, but for me, we come only for a field trip for 10 or 3 weeks, 10 days or 3 weeks. I guess it will be better to stay for a year to know more how people, local people, all the activity around those lakes. What do they do? For example, with I was wondering how the with the cattle, how it's or if people for some agricultural field, do they put some product to improve the productivity of the potatoes or other agricultural field. So I would say it's strong for sure. But how strong? I'm not sure. I just want to study that, but I'm not sure of the expertise about that. I guess some of you, all of you who are actually from Yakutia and working for a longer time with local people can answer more this question. But for sure, it's a subject that is interesting for me.
Спасибо большое, Антуан.
Thank you, Antoine. Dear colleagues, because Allah's ecosystems are closed systems with limited capacity, any influence, anthropogenic or climatic, is very strong. If near Allah's you have a settlement with a farm, with the grasslands, cattle, this Allah's becomes not natural landscape, but an anthropogenic landscape. And due to the fact that we have permafrost and the soils don't have a drainage to the underground, to groundwater, everything that's accumulated just goes down to Allah's around, and people and cattle have a lot of wastes, produce a lot of wastes. Just over several years, they can totally deteriorate any water body near, adjacent to that area, and it can and it will no longer be good for use. So to forecast or to prevent it, it's quite impossible, because even if you construct this wastewater sewerage, you should find a place where you will take this wastewater. And every territory where these waters will be dumped, they also have their own limited capacity. And people really produce a lot of wastewaters. So that's difficult questions in permafrost areas. And the solution for this question or issue I don't see in the nearest future. For example, in non-permafrost areas, farming recycles their wastes with bacteria or gas, or they somehow recycle these wastes and then use the gas to produce electric power. But here, microbes unfortunately will not work. In some years, in our soils, the microbial activity is within only 0.10%. So every year under forests and grasslands, we have tons of organics accumulated. And then it turns into a kind of a gunpowder. That's where we have these wildfires of the global scale as we had this summer. Thank you. Roman mentioned that we have 8-9 months of winter. For pollutants, it's biogeochemical stability. So there is a concept, biogeochemical state of calm or stability, and our microorganisms, they cannot fight it. So these are very special conditions in permafrost that are characteristics that are present and that will be present here. Yes, that's the continental climate. Not only permafrost, but the harsh continental climate. Yes, thank you. Roman, I have a question to you. The things that you listed are the problems of modern people, right? In the past, locals coped with these problems perfectly well. At each alas, only one family lived. It couldn't affect the quality of water or the changes in resources. As soon as we started big kolkhoz farms, that's when the problems started. Victor, I totally agree with you. In the past, the traditional cattle breeding activities was very strongly linked to the capacity of the territory. And of course, they were wise enough to rationally and effectively use their resources and distribute loads on the ecosystem. And there were no major anthropogenic effects. But for 50 years, I have been complaining that accumulation of people in one place and cattle and machinery and everything, it is very negative. But nobody hears me. In the late 80s, we initiated a movement called Sayalik, which can be translated as summer homestead. And there was a conference presented at All Union Conference, and there was even a special project, a draft of law on summer homesteads or summer farms to distribute the cattle more or less evenly across the territory of one district. And for that, roads were built, high voltage lines were constructed, but then Soviet Union collapsed and this program stopped. And again, we saw the accumulation of population in larger settlements. Thank you. Dear colleagues, our German colleagues really have to go. So let's switch to the next one, because I know you can talk all night long. Number 8. How do we facilitate, or can we facilitate, the access of local community to the water quality data? In modern conditions, yes, why not? For example, Victor is dealing with underground water. There is a lot of underground water in Yakutia, and around large lakes there are a lot of quality talik waters, and we can ensure good water supply. I think Victor will agree with me. Yes, we also have an article in our constitution that everyone has a right to access open information on the status of the environment. Also, environmental education is important, because not everyone will have time or willingness to go and find out what quality is water in my lake. So yes, the information is indeed open, in open access.
У кого-нибудь есть еще что-то дополнить по этому вопросу?
Any other additions?
I have a question. Is it something like on the environmental agency or water agency where you can access to the water quality? That was one of my questions. Is how people, because people are interested, okay, this lake can I drink or this? Is it something available or on website, or you need to get a report? Is it?
Я не понял, переведите, пожалуйста.
Ну, у нас этим вопросом занимается, в принципе,
Hydrometeorological Service is in charge of that, but the study of a certain lake, in Soviet times it was pretty well organized, especially for larger lakes, but nowadays I don't think they have enough information, because the number of stations has been cut. It was cut even more than by half, and that's why I don't know how to answer. I think the Ministry for Nature Protection might be interested in this. Thank you. The Administration of Water Resources, the Administration of Lena River Basin, no, they do not deal with quality. They get information from Hydrometeorological Service. This I know for sure. At the Ministry of Nature Protection, they have a lab. The Volkova laboratory. But how accessible are these data for population? It's a good question. It's a commercial organization, and you have to pay. By the way, I'm concerned because actually ministry has money. Why do they have to make this lab a commercial services provider? Because it's their duty to provide information to population free of charge. Exactly. Unfortunately, Ruslan, again. So if a person inquires, applies to find that information, yes, they can get some information, but there is no unified information open source system where you can find information only on demand. Hopefully it's a good answer to Antoine's question, and let's move to the next one. Does the increased withdrawal of water from Alas lakes have an impact on stability or instability of the permafrost? No, it doesn't affect it, because Alas lakes are located where the ice complexes melt. So under them there is only a permafrost layer that is far more sustainable than ice complexes. So the climate impact, anthropogenic impact influences ice complexes, inter-Alas territories. But Alas lakes are exactly in the places they don't affect permafrost too much. Yes, I agree with Roman, because Alas lakes term, it's actually a stage in the lake development. so the ice complex has already thawed, and after that the lake will either disappear or expand due to cyclical processes. So I don't think it has any impact. But other factors, yes, they can have an influence. It might actually impact, or it might not. When the water withdrawal exceeds the capacity, when you deplete the resources, when the shoreline gets out of water and it starts freezing, the thickness of talik decreases, and it influences the quantity of water. So maybe in some cases it has some influence if there is excessive withdrawal. Everything should be within the reasonable limits. Yes, to put it simple, you can drink out your lake. Actually, there were some cases in Yakutia. No, I think they will dry out naturally faster than we will manage to drink them out. Sorry, it was such an interesting discussion. If we have any questions or comments, and just some data for your information. During the war, it was a very strong drought, and there was a village, Arangastah, in Nurba district. They were forced to move it, close the school, and all the cattle that was there. They tried to melt snow in winter and give water to cattle, but it was not possible because all men were at war. And that's why an entire village was moved in the middle of winter. And the second thing about this topic. In the districts across the Lena from Yakutsk, especially during this drought, during the war, they didn't have such strong drought as we had this year. Because there are 3 water pipelines. So back then they would first fill the basins of the lakes with water, and that's why all the plans for haymaking this year, despite the drought, they were fulfilled. Otherwise we would have a catastrophe. And the third thing is that people weren't just sitting. Even in the past, they always were doing something. In the upstream of Sola River, the Sakha people built an aqueduct. The water from the lake, from one lake, was transported to the other side, and they built it from actually large timber. That was quite a large-scale project. Actually, that pipe was functioning for quite a long time. And water regimes always change. They can be positive, negative, and when you have more water in Karbasakh system, maybe Ludmila knows, there were 7 dams on that system, but they were destroyed by rainwater. And the farmers on horses were trying to save those dams, but they didn't succeed. So these processes are very complex, extremely significant for health, economy, lifestyles, for preserving our people, by the way, because Yakutsk is home to 1/3 of Yakutia's population. And what about other? And also the large part of the rest of the population lives in other big cities. So only maybe 20% live in rural areas. And I'm not even mentioning the population of cattle. It's almost 3 times or 2 times less, because they were all given out to private owners, and it happened in autumn when we were returning from field work in the autumn. All the people had cattle, but they didn't have enough hay to feed them. And especially in those years they had to kill a lot of animals. So we still haven't gotten back to the level that we had in the Soviet times. It's all in the statistics. Thank you, and sorry for deviating from the topic a little bit. Thank you. I think my internet is also very tired, so let's conclude our roundtable.
Пропадает звук.
Дискуссия.
It was a very interesting discussion. So all the participants of the roundtable, if you have something to say in the end, a concluding remark from our participants.
Краткое.
Итоговое, итог, да?
So a summary.
Okay, so
in some kind of a
should this be reflected in some kind of a document or a resolution, or are we just talking and finish with that? So what is the final result of our roundtable? What it should end with? Any proposals, maybe? Yeah, we should probably have a decision of this roundtable. Yes, I see the main organizers of ours. Well, main organizer Anna Morgenstern, she left. I mean, from the Northern Forum. This is a discussion forum, and we have Daria Dmitrievna, secretary of the Northern Forum, who has the necessary information about this. But I think that maybe we need to reach a consensus that this roundtable was very useful and that we discussed very important issues on water quality in Alas thermokarst lakes, which for Yakutia are very important, and their fate due to the climate change and global warming and anthropogenic pressure is, we care about this basically, and we should publish what issues we discussed. So we should publish some kind of result of our work in mass media, our proposals, especially since this is Northern Forum is for sustainable development. And that is why I think that we need to create something like this. Thank you.
Спасибо большое.
Thank you.
Так, Роман Васильевич, у вас какие?
Roman Vasilievich, from my point of view, within the frames of the Northern Sustainable Development Forum, we held this roundtable, and that is why I think that the resolution of this forum should have some kind of a mention of our roundtable, or I would even call it a symposium, because symposia can be of different scales, and roundtable is not a very scientific name. And to include things like these people took part, and there should be recommendations, and we should probably discuss these recommendations later. Probably Ludmila has the emails of all the participants and the organizers of the Northern Forum, and she can ask from each of you, each of our participants, to send their thoughts on the recommendations. And then all of this can be sent to the Northern Forum so that they can pass them on to specific institutions, to organizers, and so on, for all the relevant agencies and so on, to ensure the prosperity of people who live in Alas regions.
Виктор Васильевич.
Thank you, Viktor Vasilievich. I agree with Roman Vasilievich. This is a very important element of the Northern Forum, and we shouldn't call this a roundtable, because this was not a roundtable. This was a symposium. We had representatives from different countries.
Круглый стол – это получается как
Roundtable is a kind of an underestimation of our work. That is why it should be called a symposium. Well, from the beginning, this was called a discussion arena. Okay. We should, I think that each expert should voice their opinion, like should give like one point that needs to be included into the recommendations of our symposium. And we need to set a deadline, maybe until Monday or Tuesday, and ask all the experts to send it to Ludmila. Okay, I will talk with the organizers about the deadline of when we need to do this. And I think Tuesday is a realistic deadline, especially considering that it's Friday right now. And yes, I think while we still remember this symposium, we can each give one proposal, recommendation. Yes, on behalf of the participants, I would like to thank the organizers, Ruslan Mikhailovich, and you, Ludmila, for organizing this symposium. Innokenty Innokentyevich, anything you want to say? I am very happy that I took part in this discussion, and I hope that it will be the results will somehow be reflected in the Northern Forum recommendations. And thank you once again to everyone. I was very happy to see you all. Thank you, Antoine.
Спасибо большое. Спокойной ночи.
Thank you very much and good night.
8 часов вечера только.
Thank you. It's only 8 in the evening here. So it's early for us to sleep. And me, as a conclusion, would like to thank our interpreters who have worked with us for so long, 1 hour more than they were supposed to. Also, very big thank you to the organizers of the Northern Forum who gave us this opportunity to meet together. A very big thank you to our technical advisors, and I was very happy to see here today such people, such experts in their fields, and I was really, really satisfied that
Собрались, это бывает очень редко.
we all gathered together. This is a very rare opportunity for all of us. And I was very excited to listen to you, to your experiences. Thank you very much for your great work. Thank you.
Надо сказать еще большое спасибо нашему ректору.
And a big thank you to our rector who proposed this after the expedition.
На приеме он сказал, что надо
He said that you need to organize this kind of a discussion arena on this topic as quality of life. Thank you to Anatoly Nikolaevich for the idea and to everyone. It was very nice to see Innokenty Innokentyevich, Roman Vasilievich, and a big gratitude to Viktor Vasilievich and Ruslan. Thank you to you as well. And to our foreign colleagues for their interest and for all the good that they are doing for our lakes. Thank you. Bye-bye, everyone. We are working for 3 hours now, and yes, I think we should finish now. Thank you. Bye-bye.
Всего доброго, да. Всего доброго.
Всего доброго. Спасибо.